Good morning everyone. How are you students? Everything going well? Okay, so in last class we discussed about heat transfer. Okay, briefly I am giving you idea about the topics. In detail here you will study. So today we will discuss about mirror. Our topic is mirror. Do you have idea about mirror? What mirror do? Do you know about reflection? Reflection of light. Reflection of light means if light incident on any surface, then some part of light bounce back. That is known as reflection of light. Okay, so reflection of light means light incident on any surface, then some part of it bounce back in same medium known as reflection. Okay, so we understood what is reflection. Now what mirror do? So actually at mirror also reflection takes place, but why specifically we are studying mirror? Because in case of mirror, most of the part of light will bounce back. You know, we see many types of surfaces. Some surfaces are very shiny, okay, and some surfaces are very dull. Why they are dull and why any surface is very shiny? What is the reason? And best point is what, that how we see the object. So actually what happens when light incident on any object, that light reflected by the object, then that reflected light incident at our eyes. That's why this is the reason we see the object. So how we see the object? By the help of reflection. Light incident on the object, same light bounce back, okay, and after bounce back, if it is hitting at our retina, then we can see that object. It only happen in daytime, or if we see in dark night any object, we try to see any object, we are unable to see. Why? Because no light is incidenting on the object, so no reflection, no reflected light by the object. That's why we can't see the object. Is it clear? Okay. So in case of mirror, what mirror do? Mirror reflect most of the part of incident light mirror reflect most of the part of the incident light. Okay, so mirror, why these mirror are important? Because in case of mirror, reflection intensity is very high. In case of mirror, reflection intensity is very high. Okay, so we discuss about mirror also. Now type of mirror and how reflection takes place. So I think you all know laws of reflection, that incidence angle equal to reflected angle. Do you know about it? This is a plane mirror. Okay, this is incident light. So how we draw ray diagram? This is incident light. Then what we have to do? First we have to draw normal. And what is normal? Normal is a perpendicular line. What is normal? Normal is a perpendicular line. What is normal? Normal is a normal ray perpendicular to the surface. What is normal? Perpendicular to the surface. Okay, now we discuss about normal. We understood normal. Normal is what? Perpendicular to the surface. So what we have to do? this ray is incidenting here. At same point we have to draw normal. Okay, so this is normal perpendicular line. This is what? Normal. Now you know angle of incidence is equal to angle of reflection. Angle of incidence equal to angle of reflection. You all know it. Okay, what is angle of incidence? Angle made by the incident ray with the normal. This is normal, this is incident ray, this is incident ray. Okay, so this angle is angle of incidence. We represent it by I. Angle of incidence is I, angle of reflection is R. Okay, so this is I. Now what will happen? This ray will reflect. And how ray will reflect? At same angle. So reflected ray will be like this, and this angle is reflection angle, and both are equal. I equal to R. This is reflected ray. Reflected ray. So you know all these points. But what extra we will discuss here? For that you have to remember these points, then only we can discuss about spherical mirror. Plane mirror everyone know, but spherical mirror only few students know about spherical mirror. Okay, is it clear to all? So two type of mirror are there. Types of mirror. First is plane mirror and second is spherical mirror. So plane mirror is simple. In this class we will understand about spherical mirror. Clear? Today we will discuss about spherical mirror. Till now everything clear? Because all these are basic point and you studied in 10th class, I think. In which class you studied? You all send your response. This mirror topic in which class you studied? 10th class. Okay, some are saying 8th and 10th both, na? In 10th you studied in detail. Okay. Spherical mirror. These spherical mirror are of two types. One is concave and another is convex. Concave and convex. I think this point you know, concave and convex. Okay. So now we will discuss this concave and convex. So you have to read this point. Okay. What is written here? A spherical mirror is a part of a sphere. So first important point, that these spherical mirror are made of a sphere. Okay. These are the part of the sphere. Okay, this is important point. Now if one side of sphere is silvered, one side is silvered, then other side act as a reflecting surface. Then other side act as a reflecting surface. Okay, other side act as a reflecting surface. Now next, when convex face is silvered, you have to remember this point. What? This is the sphere, right? This inner outer side, this outer side, outer surface, this outer surface is convex. Okay, and this inner surface is concave. Is it clear? Outer surface convex and this inner surface is concave. Okay. Now next point. Understand this point. This inner type of mirror are two. Then how we decide type of mirror? So it depend on reflecting surface. Okay. If this outer surface is reflecting surface, then that mirror is convex. If inner surface is reflecting surface, then that mirror is concave. Then how we decide reflecting surface? If one side we silver, then another act as a reflecting surface. So if we silver this outer side, then inner side will act as a reflector. So it is concave. Okay, so inner side act as a reflector. That's why it is this inner side act as a reflector. That's why inner side act as a reflector. That's why it is what? Concave. Here you can see we silvered inner side, then this outer side act as a reflector. This outer side act as a reflector. That's why it is convex. Is it clear? So we understood type of mirror, concave and convex, type of spherical mirror, how a concave mirror can be formed, and this convex, that also we discussed. That if we cut, we have this sphere, okay, we are cutting this sphere like this, okay, then we have two part, one part this one, another part this one. If we polish this inner side, then outer side act as a reflector, then this mirror will be convex. Okay, if we polish this outer side, then this inner side act as a reflector, that's why it is concave. Clear? Okay, now understand this point. You know, these both mirror are the part of sphere. Now what sphere has? Sphere has center and radius. Agree or not? This is the center of the sphere, right? This is the center of the sphere, right? And sphere has radius also. This is radius of the sphere r. Agree or not? So a sphere has center and radius. So center of curvature and radius of curvature. Curvature means this is this part of the sphere, that's why we call it curvature. So what is the meaning of curvature? A part of the sphere is known as curvature. Okay, a part of the sphere is known as curvature. Okay, so center of the curvature, so whatever center of the spheres, that is the center of curvature, because curvature is the part of sphere. Okay, now radius of the curvature, so whatever radius of this sphere, same radius for curvature. Okay, now pole of the mirror. So what is pole of mirror? Pole of the mirror, so this is new for us. Pole means geometric center of the mirror or curvature, or we can say midpoint of this curvature. So where is the midpoint of this curvature? So midpoint is here. Where is the midpoint? Almost here, right or not? So this is what? This is pole. Okay, so this midpoint, this point is pole, this point is pole. Okay, now principal axis. What is principal axis? Principal axis is the line passing through the pole and center of curvature. Okay, to tell me where is the center of this curvature, so you can say, sir, center of this curvature will be this side. Agree or not? Because this curvature is the part of this sphere, right? So its center will be this side. Agree or not? So this is center, and this curvature center also, this curvature is the part of this sphere, so this curvature center also this side. So we can draw a new diagram and we can understand principal axis. So what is principal axis here? You can understand in this diagram. This is what pole and this is what center. So a line which joins center to pole, this line, you can extend this line, so it is what principal axis. Okay, we understood principal axis. Next is normal. Normal already we discussed. Normal means perpendicular. So any line joining the mirror to its center of curvature is a normal. Any line joining the mirror to its center of curvature, normal means perpendicular. So if we join any point of the surface with center, so this line is perpendicular. Agree or not? Any point of the surface to the center, then this line is perpendicular. So this line act like a normal. What is normal? Any line joining the mirror to its center of curvature is normal. So this line act like a normal. Okay, so these definitions are important. We will use all these definitions. Okay. Now next point, sign convention. Sign convention means actually here what mirror do? In plane mirror at our home we see our image. Agree or not? So we use mirror to see the image. Agree? Okay, so object is there. That object image is formed by the mirror. Okay, so this mirror, what mirror do? It establishes a relation between object and its image. Agree or not? Okay, so we have to understand here that where object is placed, for that particular object where image will form. Okay, so is there any relation between object distance and image distance? From where we will measure these distance? From the mirror. And in mirror from where? From the pole. So what is pole? Pole is this pole is act like origin. Normally in Cartesian system we decide coordinates, x coordinate, y coordinate, and we decide their values also. Okay, suppose here is the object, so you write its coordinate 2, 3. So 2 is this distance, okay, and 3 is this distance, right or not? So these 2 and 3 both decided from this point, right or not? We call this point origin. So all distance decided from the origin in Cartesian system. Here in case of mirror, all distance we decide from the pole. Is it clear? So very important point, that here all distance are measured from the pole. Okay, I am underlining this point. All distance are measured from the pole of the mirror. Okay, now next point, in Cartesian system, we call it Cartesian system, this side plus, this side minus, this x-axis, this side positive, and this side it is negative. Okay, this side it is negative. Y-axis, this side positive, and this side it is negative. You know it. Okay, so here which side is positive, which side is negative, how we decide? So first point, what? Incident light direction is positive and opposite to incident light negative. Okay, what is the point? That incident light direction is positive and opposite to it negative. incident light direction positive and opposite to it negative. We will use all these points to solve the questions. Therefore, you have to understand this point. So, incident light direction is positive and opposite to it negative. Means if object is here, so from the object light will incident on the mirror like this. So this direction positive, because everything we will calculate from the pole. So this direction positive and this direction negative. Agree? Okay. Now next, above the principal axis, this is principal axis, already we discussed, a line which join pole to center, that line is principal axis. So above it positive and below it negative. So upward positive, downward negative, this side negative, this side positive. Is it clear? Okay. To be understood. Now next, here we defined one more point, that is focus. So what is focus? Understand. What is focus? First I am drawing here ray diagram. By the ray diagram we will write the definition. It will be very simple. This is what, which mirror it is? So it is concave mirror, right? This is concave mirror. Now how to draw ray diagram? Understand. First assign its pole. So where is the pole? Here is the pole. Okay. Where is the center? This side. Center is this side. Suppose here is the center. Suppose. Okay. Now draw principal axis. To join center to pole, that line is principal axis. So this is principal axis. Okay. This is principal axis. Okay. Now we have to draw here, this is principal axis, center, this is pole. Okay. Suppose here is the object. First we will incident on this mirror parallel lines like this. Okay. So this line is incidenting on the mirror. From where it is coming? So from where it is coming, if you extend, then you can extend continuously, because it is what? It is straight line. Okay. So from where it is started, we don't know, right? Because it is straight line. Okay. So this ray is incidenting here. We have to make here reflected ray. So how to draw reflected ray from this incident ray? Understand. So first we need normal, because here what incident will take place? Reflection. For reflection, incidence angle equal to reflected angle. Okay. So we need here normal. Now how normal can be drawn? Many students are responding that this ray is coming from infinity. Yes, it is coming, but I can't use this name infinity, because you are not very much clear about this infinity. That's why I am using only known words. Okay. Because infinity, we can say normally infinity, but what is the sense of infinity? You do not know about it. That's why I am not using that word. Okay. But some students have information about it. Very good. You have knowledge about it. Very good. So now we have to draw normal. How to draw normal? Already we discussed that join the point of this curvature with the center. That will be the normal. Okay. So we are drawing normal here. This is normal. Okay. Now we drawn the normal. So one thing we know, what? That incidence angle, this angle is angle of incidence. Incidence angle is equal to reflection angle. Okay. So angle of reflection is, the ray will reflect like this, so that this ray will reflect like this. Okay. And here we can say that this angle of incidence and this angle of reflection both are equal. Agree? Okay. So here This is what reflected ray. Now if we use one more incident ray, this side, this is incident ray, okay, this is incident ray, okay, this ray also parallel. How it will reflect? So first we have to draw normal here, join this point with the center, this is center, okay, so this is normal. Now angle of incidence equal to angle of reflection, okay, so how it will reflect? So it will reflect like this, okay, this is reflected ray, this is also reflected ray, both reflected ray are intersecting here. Both reflected ray are intersecting here. This intersection point is known as focus. This intersection point is known as focus. Now what is focus? What you can say about focus? Generally in suppose in dark night you want to see any particular object, you switch on torch, then what you say? Are focus here, okay, like that we use word focus here. So focus means most of the light should incident that point. So after reflection, this all reflected ray cut at a particular point. That particular point is known as focus. Is it clear? Okay. So what is focus? Focus is the intersection point of parallel incident rays, and these are parallel with principal axis, okay. So all parallel incident rays after reflection meet at focus. Clear? So we discuss about concave mirror. Now we will discuss about convex mirror. In case of convex mirror is like this, okay. So here also first to draw principal axis, this is principal axis, this is what center, this is what pole, this is center. Now draw parallel rays parallel with principal axis, okay. So we drawn these parallel rays. Two rays we will use here. How they will reflect? So first we have to draw here normal, this is normal, here also normal we have to draw, okay. So join this point, okay. Now incidence angle equal to, this is angle of incidence, this is angle of incidence. So incidence angle equal to reflect angle of reflection. So how they will reflect? Like this. How they will reflect? Like this, okay. Now these reflected rays, are they intersecting? No, right or not? Here they are not intersecting, okay. So if they are not intersecting means, if they are not intersecting, then here normal does not exist. No, normal will exist, but how we will define normal here? Understand. If we extend these rays back, like this, so these rays seems to meet here, right or not? These rays seems to meet here, so this point is known as focus. This point is known as focus. Is it clear? Okay. So we discuss about the focus. Now ultimately what definition we have to write here about focus? So we can say reflected rays actually they can meet, or it seems to meet, right or not? These are diverging from here, seems to diverging, right or not? Actually they are not diverging from this point, but any person who is this side, that person can say that these rays are coming from this point, right or not? So we can say that these are seems to diverge, seems to diverge. Okay, so here we can say that parallel rays, parallel rays after reflection, otherwise here actually one more word is there, paraxial rays, we can use that word, paraxial rays. Paraxial rays means rays which are parallel to principal axis. So paraxial rays after reflection intersect or seems to intersect at focus. Okay, and paraxial rays means you can understand the definition of paraxial rays, which are parallel to principal axis, which are parallel to principal axis. Principal axis. Okay, so these are parallel to principal axis, incidenting after reflection, they are intersecting to focus. They are not intersecting, but if we extend them, then seems to intersect here. So then here also we will say this is focus. Is it clear? Okay, so we understood it. Now next point, real object and virtual object, real image and virtual image. How to find that this object is real, how to find that this image is real. Okay, that we will understand in next class. Okay students, so today we understood about some important points of the spherical mirror. First we discussed what is reflection, means bounce back of light. Mirror, why we use mirror? Because they bounce back most of the incident light. Okay, type of mirror are two. Here we discuss spherical mirror, concave and convex. These are the part of sphere. Okay, if we silver inside surface, then outside act as a reflector. Outside reflector surface is convex, and if we silver outside surface, then inside surface act as a reflector. So this is concave. These are the part of sphere. That's why these mirror has center, radius. Okay, pole is new. Pole meaning is midpoint of this curvature. Midpoint of this curvature. Normal, any point which join the any line which join the any point of the curvature and center, that is what? Normal. Okay, so all these points we discuss. Here we discuss sign convention. This one also we will use. Incident ray direction is positive and opposite to it negative. Above the principal axis positive and below it negative. All these we discuss. Okay, then we discuss that what is the meaning of focus. By ray diagram I tried to explain you about focus. So rays which are parallel to principal axis, they incident after reflection, they meet, they cut at a particular point, that is focus. Here they are not cutting, but if we extend them back, then seems to meet here. So this is also focus. This focus is for convex mirror and this focus is for concave mirror. So very important point, in case of concave mirror, center is this side, this is center, focus all are one side. Here also pole, focus, center all are one side. Okay, so further we will discuss tomorrow. Okay, so I hope you all enjoyed this session and you understood all these points. These will be very helpful. in next 2 years. Okay students.
Good morning everyone. So yesterday we have seen types of various redox reactions. Let's see some problems on that. Then we will go to the next topic. Okay. So which of the following is a redox reaction? So first below 4 reactions are given. Which one is actually a redox reaction? Redox means what? Reduction means change in oxidation state should happen. Increase in oxidation state should be there, as well as decrease in oxidation state should be there in a given reaction. Okay. To know that, first we have to write the oxidation states. Now, forget about this number given, focus on the substance only. Sodium oxidation state is what? Group 1 element +1, and when it is +1, chlorine will be automatically -1, so that overall should be 0. Next, H2SO4. Sulfur and oxygens are non-metals. So with non-metals, if hydrogen is joined, it will have +1, and SO4 in that oxygen -2. When oxygen -2, hydrogen +1. What is the sulfur oxidation state? How to find? See, H2SO4 +1 X -2. So 2 hydrogens are there. 2 into +1, 2. 1 sulfur, 1 into X, 4 oxygens, 4 into -2, -8 is equal to overall charge is 0. So you will get X as +6. In this way, you have to find. Okay. So sulfur is +6. Similarly, again SO4 is there. SO4 is there means always will be the same oxidation states will be there. Oxygen -2. Same way sulfur +6 we will get. Sodium means +1, group 1 element. Hydrogen +1. Don't focus on this number. That is useless for us to find oxidation states. Focus on only the compound. Hydrogen +1, chlorine -1. Now, any oxidation state is changing. Sodium no change, chlorine no change, sulfur also no change, hydrogen also no change. So, no one is changing their oxidation states. So, it is not a redox reaction. Now, similarly, if you write hydrogen +1 and silver in the compounds, it exhibits only one oxidation state, that is +1. And NO3, oxygen, if you take -2, and same in the same procedure, if you find out this, you will get +5 nitrogen. And right side silver always +1 in its compounds, halogen therefore -1, hydrogen +1 when it is combined with non-metals, and since NO3 is again repeated, here +5 -2 also will be there for NO3. Same states will be there. If same radical formula is repeated, like NO3, SO4, carbonate, CO3, like that, if same radical is repeated, oxidation states also will be the same in both. So if anyone is changing, here also nothing is changing here. No oxidation state is changing here. So it is also not a redox. And this is the acid-base reaction. Acid-base reactions are always non-redox. You can directly put. Okay. Even if you find also, you will get the same. So acid-base reactions also sodium +1, oxygen -2, hydrogen +1. So no oxidation state change in the acid-base reactions. Finally, H2Br2 gives HBr. Hydrogen elementary state 0, bromine elementary state. Yesterday I explained what is the difference between element and compound. Now HBr, hydrogen +1 and halogen, that is bromine -1. So here hydrogen is changing oxidation state, bromine is also changing. So this is the redox reaction. Is it understood everyone how to find oxidation states and how to decide? Next, which of the following is not a redox reaction? Okay, see, in the same manner like earlier problem, we have to see here hydrogen +1, then sulfur has to be -2, because 2 into +1, if you take as x, 2 into +1 plus x should be equal to charge. When you do that, you will get sulfur -2. Oxygen -2, sulfur +4 you will get. Hydrogen +1, oxygen -2. Elementary state means is not combined with any other element means 0. Now here oxidation states are changing. Sulfur is changing as well as sulfur is undergoing change, only sulfur is undergoing change, -2 + 4 sulfur is going to 0. So there is a change in oxidation state, means redox. Now if you look at the second one, barium +2, oxygen -2, elementary oxygen means 0, barium +2, oxygen -2. Now here oxygen is undergoing the change in oxidation state, oxygen 0 state, it is changing there. So therefore, so here actually it is a barium +2 means oxygen you will get -1 here. So anyway, oxygen is changing oxidation state here. So this is also a redox reaction. Here are two oxygens -2, 0. They are changing into -1 state. Some oxygens are increasing their oxidation number. Some oxygens are decreasing their oxidation number. So redox reaction only. Next, again barium +2, oxygen -1, hydrogen +1, sulfur. We have calculated in the previous page. Sulfur +6, oxygen -2. H2O2. Yesterday I mentioned H2O2 is called hydrogen peroxide. So oxygen -1 there. It is also, so if you see barium +2, sulfur +6, same only, hydrogen +1 and oxygen -1. So here there is nothing, you will see no change in any oxidation states here of any element. So therefore this is a non-redox reaction. This one is a redox reaction. Yesterday we have seen this example also. Potassium and oxygen -2, potassium +1 if you take, and by taking chlorine as X, you can find the oxidation state of chlorine by taking the sum of all oxidation states as charge, that is 0. Yesterday we have solved this. And in this case, potassium +1 means chlorine has to be -1, elementary state means 0. So here also oxidation states are changing. So only third option is the correct one. Okay. In the reaction, Cl2 + OH- gives this. Chlorine is what? Chlorine is oxidized or reduced. Okay. See, Cl2, elementary state. Elementary state means oxidation state is 0. And OH, hydrogen +1, oxygen -2. Oxygen generally -2 we already know. And hydrogen when it is with non-metal +1. So +1, -2. And chlorine, see when only chlorine is there and it has charge what? -1. Then in case of ion, then whatever the charge is there, that is the oxidation state. So chlorine here oxidation state is charge, that is -1. And ClO4, here if you take chlorine as X, oxygen as -2, oxygen oxides -2 only, and take the sum of all oxidation state equal to charge. What is the charge here? -1. You will get chlorine has +7. Then only see 7 into 1, 1 chlorine, 4 oxygens into -2. Overall if you add, okay, 1 into 7 plus 4 into -2, if you add, you will get -1, the charge of the ion. And hydrogen +1, oxygen -2. This is where you have to find first oxidation states. Then see, chlorine is what? Chlorine is oxidizing or reducing, they are saying. Chlorine is going from 0 state to -1 as well as +1. Means 0 to -1 means increase in oxidation state. 0 to -1 means decrease in oxidation state. 0 to +7 means increase in oxidation state. So chlorine is undergoing oxidation as well as reduction. So oxidized as well as reduced. This is the answer. I hope it is understood. Next, which of the following does not represent disproportionation reaction? So yesterday we have seen disproportionation. If same element is getting oxidized as well as same element undergoes reduction, then that is called the disproportionation. Okay. See, MnO2. Here, what is the oxidation state? Oxygen -2. If oxygen -2, what will be the oxidation state of manganese? If you take it as X, X into 1 manganese, 2 oxygens, each one -2, 2 into -2. So what is the summation if you add overall? See, MnO2, I am showing 2, 3 compounds. and after that I will directly put the values. See, MnO2, so 1 into X because 1 manganese, 2 oxygens, each one minus 2. Sum of all oxidation states of all elements in species is equal to the charge. Charge is what? Nothing. It is not an ion. So 0. So by doing that you will get X as plus 4. Okay. Similarly, you can find here all simple things only. You can find others also. I am directly writing here first. So X is what? X value is, we got plus 4 manganese. Hydrogen. Look at the only compound. Hydrogen plus 1, then chlorine has to be minus 1. Manganese. See, chlorine minus 1. Generally, manganese therefore will be plus 2. Halogen's general oxidation state is minus 1. Chlorine, fluorine, bromine, etc. So minus 1 you take, then manganese will be plus 2. Then only if you add all the atoms oxidation state, you will get the charge, which is 0. Elementary state means 0. Now, is it a disproportionation? Manganese is going from plus 4 to plus 2. Fine. But chlorine is getting oxidized. So, same element should undergo oxidation and reduction. So, manganese is undergoing reduction, chlorine is undergoing oxidation. So, this is not a disproportionation. Look at the second one. Say, hydrogen is given. Hydrogen, this is hydrogen peroxide. I told you to remember. H2O is water, H2O2 is hydrogen peroxide. Peroxides means oxygen oxidation state will be minus 1. Even if you take hydrogen plus 1 and oxygen X, and if you find that X value, you will get minus 1 only. And in normal H2O formula, hydrogen plus 1, oxygen minus 2. Elementary oxygen means 0. Now see, oxygen is only undergoing oxidation and same oxygen is only undergoing reduction. See, oxygen is going from minus 1 to minus 2 means reduction. Oxygen is going from minus 1 to 0, oxidation. Same element is going both ways. Therefore, second one is the disproportionation reaction. But they are saying which of the following example does not represent disproportionation. Already we got first reaction is not a disproportionation reaction. So according to the given question, does not represent. Therefore, answer will be first one. Second one is a disproportionation. First one is not disproportionation. This also you have to be careful in exams. When question is asked, sometimes they will ask which of the following is not correct. So by the time when we read options, we will forget that question what is given. We will check for the right statements only, and once we confirm that okay, this is right statement, B option is right, when we confirm that, then we immediately put that without reading the question again. So this comes through experience. So remember, when you read a question, if incorrect is given, immediately you box it, or if does not is given, you circle it first, so that you don't make any mistake while selecting the right option. In KClO3 also you can see chlorine goes from plus 5 state to plus 7 state and minus 1. I am writing directly, you can find out afterwards and check. And chlorine is going from 0 state to minus 1 state and plus 5 state. Same element is undergoing oxidation. So second, third, fourth are disproportionation, first is not. Okay. I'll stop here and I will take up the next concept, balancing the redox reactions. Now see, when it comes to balancing of redox reactions, balancing means what? Left side and right side same number of same atoms will be there. Suppose sulfur is 2 atoms on the left side, right side also it should be 2. If oxygen is 4, here also 4. Like that, atoms should be balanced on both sides. Not only that, redox means electrons transfer takes place, something lose electrons, something gain electrons. These electrons also must be balanced. Then only it should be called as a balanced redox reaction. Because if something is losing more electrons but other one is not gaining that much electrons, then the equation we should say it is a not balanced reaction. So for a redox reaction to be called as balanced, two things should be happening. One is atoms should balance, which you already must be aware of already. Second one is electrons also must balance. Okay. Now, I will tell one method called oxidation number method. With that, you can balance any redox reactions. Automatically, atoms and electrons will get balanced. Now, what are the steps in that balancing? See, first I will take one example and I will show you, explain with that example, all the steps. Here H2SO4 plus carbon gives CO2, SO2, H2. One is the trial and error method. You will see, you will put different numbers and see whether it is balanced or not. That is a very crude method. Sometimes it may take more time also. But if you know the method, various steps, then you can get easily for any redox reaction. Initially, it may take some time to understand, but once you are get a grip of it, then it will be very easy. Within few seconds only, you can balance. Anyway, first see the steps, understand step by step. The first step is balance. First, find the oxidation states. Oxidation states you need to find and focus only on those elements which are changing their oxidation numbers. From reactants to products, when they are forming, change is happening. Only focus on those elements only. Okay, now if you write oxidation states here, hydrogen +1, oxygen -2, if you find sulfur, you will get +6. Carbon, elementary state, not combined with any other element, is called elementary state, 0. Oxygen -2. What will be the carbon? Carbon has to be +4. Then only overall summation will be 0, oxidation charge. Now oxygen -2, sulfur +4, hydrogen +1. Writing oxidation number is very crucial. For that, a practice is required. Now, once you write, then which elements I have to focus? Which is changing their oxidation numbers, you see? Which is changing their oxidation numbers? Sulfur. See, sulfur is going from +6 to +4. And what is the other element? Carbon. These two elements only are changing their oxidation states. Now, whichever element is changing their oxidation states, balance the atoms undergoing oxidation, change in oxidation state. First step is what? First see the oxidation numbers, and wherever a change is happening, first focus on those elements only, balance them. How you balance? Directly. If 2 are there, put 2 here. 3 atoms are there, put 3. Like that, directly balance. Now see, 1 sulfur is there. Here also 1 sulfur. Fine. 1 carbon is there. Here also 1 carbon. So in this example, we don't bother because already they are balanced, the atoms. Second. Now second step is take the total change in oxidation state. Calculate. I will explain what it means. Calculate total change in oxidation state. For the elements undergoing change. Whichever is our elements undergoing change in oxidation state, find the total change value and then cross multiply with respective substances. What does it mean? See, I will write the equation again, don't worry. See, H2SO4 plus carbon, CO2, SO2, H2O. In that, what is undergoing change? Sulfur. I am focusing only on those elements which are changing. Sulfur is going from +6 to +4. Carbon 0 to +4. Now, from sulfur, for sulfur, what is the total change? What is the change? +6 to +4 means what is the change? Positive change only you have to calculate. So, what is the positive change? 6 minus 4, 2. How many sulfurs are involved? For one sulfur change is 2 means how many sulfurs are there here involved? As you see, one sulfur only. Sometimes in the reaction, if 2 sulfurs are there, for one sulfur change is if 2, then 2 sulfurs total change will be 2 into 2. Like that you have to do. That's why I have mentioned here total change. Okay, so 6 minus 4 change is what? 2. Total change 2. Okay. Now, what about carbon? Here, similarly, carbon also. See, carbon is going from 0 to +4. 0 to +4. What is the total change? 0 to +4 means positive change is what? 4. How many carbons are involved? 1 only. So, total change will be here 4. And actually this change, whatever we are discussing, it happens because of electron involvement. So, suppose if they ask you from 0 to +4, when carbon is changing, how many electrons are involved? So, what is the difference in oxidation state? That is the number of electrons involved. Similarly, here also, for sulfur change from one H2SO4 to one SO2, for one sulfur, if how many electrons are involved, as you see here, change in oxidation state is the number of electrons involved. Okay. Now, after getting this, take the ratio, cross multiply the ratio. So, if you see here, once you calculate the change, cross multiply the ratio with respective substances. Meaning what? See, what is the ratio? See, here 4, here 2. What is the ratio? Calculate. 4 is to 2 means 2 is to 1. So, sulfur, carbon. What is the ratio we got? Sulfur, actual sulfur number is what? 2. Carbon number is 4. So, 2 is to 4 means 1 is to 2. This is the ratio. After getting the ratio, cross multiply. Listen carefully. This is most important. What is cross multiply? All the sulfur substances, you have to multiply sulfur substances. You have to multiply with number 2. Carbon substances, you have to multiply with 1. Which side substances are? Both sides, reactants and products. For example, see, sulfur substances, let's multiply with 2. Where are the sulfur substances? This is sulfur substance H2SO4. This is also a sulfur substance. So, this you have to multiply with which number? 2. So, let's write that. Once again, I am writing here H2SO4 plus carbon, CO2, SO2, H2O. I am not writing oxidation states now. I am just focusing on cross multiplication. What is the cross multiplying? Sulfur number you have to multiply with sulfur compound, you have to multiply with number 2. Here also sulfur compound 2. Okay. Now carbon. Carbon compounds you have to multiply with 1. If you multiply with 1, it does not change anything. So same thing only will be. Already if nothing is mentioned means, 1 is there already. 1 into 1 means 1 only. You don't get any change. So you need not do anything there. Now, this is the second step, which is the most important step. What is that? Take the total change and then cross multiply. Okay. Then, so in this process, what we are doing actually when we are cross multiplying, what is happening in the behind? We are actually equalizing the electrons, because change in oxidation state it causes because of electrons only, and when we cross multiply, these electron transfer getting equal. Number of electrons lost in the oxidation process is getting equalized to the electrons gained in the reduction process. That's what we achieved by cross multiplying this, because electrons also must balance in the redox when we are balancing the redox. Okay, that automatically happened. Okay, that's it. With this, now after this step, third step is very simple. That is, just balance any other atoms are there in the equation, balance them directly. No method with that. So what are the other atoms? Sulfur, carbon already we have taken care. What are the other atoms present in the equation? Oxygen, hydrogen. Balance them. And among them, you take either a hydrogen or oxygen, automatically other one will get balanced. You need not bother about any one you take. Now, let's take hydrogens. How many hydrogens are there? So, first let me write that equation. Last step is what? Third one, balance other elements. That's it. Other elements here, hydrogen, oxygen. Let's balance them. So, I'm writing actually again 2 H2SO4 plus carbon, CO2, SO2 and H2O. Now, balancing the hydrogens. See how many hydrogens are there left side? 4. Right side, where is the hydrogen? Here. So, we want 4. So, just put the number 4 here. That's it. Sorry, we want 4 hydrogens, put 2 here. So, 2 into 2, 4 hydrogens. Here also 4 hydrogens. Automatically oxygens get balanced. We can check. See how many oxygens are there left side? 2 into 4, 8. So, right side also must be 8. See, here 2 oxygens, here 4 oxygens, here 2 oxygens, 8 oxygens. So, first write the oxidation state. First write the oxidation states. See which are undergoing change. Okay. Find the total change. Take the ratio and cross multiply. After that, if remaining atoms, hydrogen or oxygen, whatever remaining are there, balance them. This is the balancing steps. With one small example, I will finish, and tomorrow we will see more. I hope it is understood. If not, look at the second example, can understand. Now see, FeCl3 plus SnCl2 gives FeCl2 plus SnCl4. Now, in this reaction, we have to balance. First, find the oxidation states. Normally, halogens means fluorine, chlorine, bromine, iodine. When they are connected with the metals, so in those salts, their general oxidation state is -1. For which one? Halogens, fluorine, chlorine, bromine, iodine. When they are connected with the metals, that is when they are in the form of salts, by combining with metals, they have which oxidation state generally? -1. When they are combined with non-metals, they may change, but with metals, when they are combining, halogens have -1 general state. So, chlorine -1, here also chlorine -1, chlorine -1, chlorine -1 I am putting, because iron and tin are the metals. So, chlorine I am putting -1. Now, let's focus on the iron. If chlorine is -1, what should be the iron oxidation state? So that overall oxidation state will be equal to the 0. This has to be +3. Then only summation is 0. So, +2, +2, +4. Now, which is undergoing actually change? Iron and tin. So, iron is going from 3 to 2 means what is the change? 3 minus 2, what is the positive change? 1. Similarly, tin is going from +2 to +4. What is the positive change? 2. So, we found the total change. What is the ratio? Already ratio is 1:2 only ratio. So, now cross multiply means iron is to tin ratio is, iron ratio is what? 1. Tin ratio is 2. You have to multiply iron compounds with 2, tin compounds with 1. So, first let me write again FeCl3, SnCl2, FeCl2, SnCl2. Now, multiply the iron compounds with number 2, tin compounds with number 1. 1 means nothing, you have to do, leave it like that only. So now, FeCl3 plus SnCl2 gives FeCl2 plus SnCl4, iron plus 3 state to plus 2 state, and tin going from plus 2 state to plus 4 state. So change is 2 here, tin changes 2 and iron changes 1. So you have to multiply tin compounds with 1 and iron compounds with 2. Sorry, here I write SnCl4. Here I have written SnCl2. This is SnCl4. This is the compound here. That's it. Now, is there any other atoms besides these atoms? Iron, tin is taken care. What are the other atoms? Chlorine. There is nothing else is present. See whether chlorine is balanced or not. 2 into 3, 6 plus 2 chlorines. 8 chlorines are there here left side. 2 into 2, 4 chlorines. 4, 8. Already chlorines are also balanced here. Because already when we fix the numbers here, 2, 1, 2, 1, these 4 compounds numbers are already fixed by this step. So, therefore automatically everything in that will get balanced. If any other elements like hydrogen, oxygen is there, we should take care of them, but here is not necessary. So this is how balancing redox reaction works. I hope it is understood. Write in chat whether it is understood or not. Tomorrow we will see few more examples balancing. Okay. And again go through only 3 steps I taught. First step is finding the oxidation state and see whichever is changing. Second is the most important. Okay. Second step what I said, find the total change and take the ratio of the change and cross multiply with the products. That's it. This is the most important step. Okay. First step and third step is simple steps. So go through it up to here. Tomorrow we will see few examples, few problems on this. Okay. Thank you.
Students, good morning. Good morning, Nana. Today our botany topic is the algae. Algae is the primitive plants in the plant kingdom. Very simplest plants. In course of evolution, the first formed plants in the plant kingdom, algae. What are the characters of algae? These are algal members. All the members of the algae is chlorophyll bearing. That's why these are autotrophic, photosynthetic. These are independents or dependents. All algal members are independents. Statement true. How can you give the reason for chlorophyllous nature of algae? Due to the presence of photosynthetic cell organelles like chloroplast. Inside of such chloroplast, chlorophyll pigments are present. Such chlorophyll pigments are able to harvest light energy to convert that is into chemical energy. Second one, structurally very simpler. All algal members are structurally very simple. How can you say algae are simpler in structure? The body of the algae, plant body of the algae, not differentiable into root, stem, leaf, flowers. All these organs are absent. Root absent, stem absent, leaf, flower, seed, fruit, everything absent. But what is there? Just a green coloration, a mass or filament like cells are there. Green colored mass, filamental like structure. That is the thallus. Thalloid body. Algal body is also called as the thalloids. Thallus. Can you give definition for thallus in examination point of view? What is thallus? Thallus is the plant body not differentiable into root, stem, leaf like structures. The plant body which cannot be differentiable into root like, stem like, leaf like structures. That is the thallus. Presence of thallus is the one of the major characteristic feature of algae. Observe here, root, leaf, just green colored, a large slimy mass found on surface of water, inside of water, and wet localities, fully moist localities, also covered with a green colored mass. Next, point number 3, third point, plant body thalloid. Number 4, autotrophic. Chlorophyll, presence of chlorophyll leads to photosynthetical, nothing but autotrophic in nature. Autotrophic is the kind of nutrition algae assertion. Reason, because these are chlorophyllous. Chlorophyllous structures leads to the autotrophic nutrition or photosynthetical nutrition. Next, habitat of the algae is aquatic. Mostly 99% of the algal members are grown in water. That is meaning for aquatic habitats. Very few are terrestrial. Almost all, not only 99.99% of the algal members are aquatic. Next, both fresh water and marine water. Aquatic means water kadra. So the water both fresh water, marine water. Fresh water, stagnant water and running water. In ponds, lakes, ditches, water is stagnant. Some kind of algal members are very much likely to grow on stagnant water. Whereas another kind of algae are able to grow on running water like water in canals and rivers. Prawn or hold fast. Yes, in some are advanced algae to fix on substrate of the aquatic habitats, a hold fast like structure is present. Green color body is found in some kind of algae. A large green color mass is there. This photosynthetical part is the frond, F-R-O-N-D, frond. At bottom, for the purpose of the fixation on substrate, one structure it is called hold fast. Hold fast. This kind of differentiation of the algal body into hold fast and frond is found in some brown algae. I will explain. After half an hour class, we will go to this kind of structures. They occur in variety of other habitats. Mostly water, but some are in moisture stones, moisture wood and soil. It is a moisture stone. Moisture wood, this kind of wood or tree trunk surface, tree trunk commonly found in deep forest or in evergreen forest. Surface of the plant tree is fully moistured. It is completely purely aquatic habitat. Water surface completely studded with many algal members, different types of habitats of the algae. Some of the algae also associated with fungi, symbiotic associated with fungi. Such associations are called lichens. Lichen is not a single organism. Lichen is not a single organism. It is a combination of two organisms. In that one part is the fungal part is there. Fungal part, another one is the algal part. In a lichen organism, two parts are there, algal part and fungal part. Algae provide food for the fungi. In turn, fungi provide both shelter and water minerals from soil. Fungi is the most efficient to absorb minerals and water from soil. In there, some amount of water supplied to the algae. This kind of mutual beneficial association between these two organisms is a symbiosis. Symbiosis. Once give the definition for symbiosis. A mutual beneficial association is found between algae and fungi. Now, mycorrhiza is a different class. Mycorrhiza, fungi, rhiza, root system of higher plants. It is also a symbiotic association is found between fungal members to the roots of higher plants in the mycorrhizal association. So, both mycorrhiza and lichens are example for symbiotes or symbiotic association. Yes, algal partner, fungal partner, both are there, two parts are there, lichen. And some kind of animals also provide shelter for algae. What kind of animal? Sloth bear animal. Because the surface of the sloth bear organism fully moistured. That moisture surface of the skin or spur is the favoring place for growth of some algae. With the lichens images. Sloth bear animal. What is the actual original hair color of this sloth bear? Black color. But here green color visible. It is the association of algae with this hair or spur. That black color hair turn into green color due to the growth of algae. Next point. In terms of the size of the algae also variable. One algal size is different from another algal members. Some are unicellular. Example, chlamydomonas, entire algal body made up of only one cell like bacteria. Unicellular algae. Example for unicellular, chlamydomonas. Next, multicellular forms, colonial forms also there. Volvox example for colonial form. It is the one colony. Within the colony, each and every green color dot is the one Volvox organism or algal member. A group of algae together to form one association. It is a colony. in the species Volvox, genera Volvox. Next, some are filamentous. These are long filamentous, microscopically zoomed diagrams. These are or magnified diagrams, long filamentous structures. So based on size and shape, algae are mainly classified into three categories. One is unicellular, second colony forms, third filamentous forms. Three types. Once recollect the three types of algal forms: unicellular, second one colonial form, third one filamentous. Yes, three forms. Example for unicellular, Chlamydomonas. Colony, Volvox, and one more example is there, that is the Eulothrix. In new textbook, this example is given. Not Eulothrix, Adorina, Volvox are example for colonial forms. Next, Spirogyra and Eulothrix are example for filamentous forms. Eulothrix, this filament, it is a Spirogyra filament. Whereas in marine algae, a massive plant body is there, marine algae. Largest plant body, massive. Sometimes it may spread over hundreds of meters. Such are called kelp. All these are kelps. Kelps are commonly found in marine forms. There is also one more example for kelp. Next point, cell wall structure of algae. Made up of two types of chemical compounds. One is the cellulose, as in higher plants, and other polysaccharide, nothing but carbohydrates. Example for this kind of carbohydrates, pectin. In majority of the algae, cell wall is made up of two layers. Inner layer, innermost layer, and outermost layer, both are there. Innermost layer is always made up of cellulose only, but outer layer made up of either pectin or other substances different from algae to algae or group to group. But inner layer is the commonly made up of cellulose only. Outer layer made up of either pectin or algin or carrageen chemical material. Carrageen materials, algin or pectin. That outer layer of the cell wall made from different types of chemicals. They are variable from algae to algae. But inner layer is commonly cellulosic layer. It is about the cell wall chemical composition in algal members. Next point, in addition to the chlorophyll and other types of pigments also found in algae. Remember one thing here, as we seen all the plants in plant kingdom, higher plants, angiosperms are higher plants, highly advanced, no doubt. But in terms of the photosynthetic pigments, algae can exhibit greatest diversity. All types of photosynthetic pigments are found in this universe, found in algae. Algae possess all types of photosynthetic pigments. It means algae can exhibit greatest diversity in types of photosynthetic pigments. Based on these concepts, I will make one question here. Various types of, question is here, various types of photosynthetic pigments are found in or present in option 1 algae, second option bryophytes, third option pteridophytes, fourth option higher plants like angiosperms. Try to give correct answer. Various types of, majority of the photosynthetic pigments are found in chlorophylls, carotenoids, and some kind of special pigments like phycobilins, carotenoids, chlorophylls. In chlorophyll, A type, B type, C type are there. Carotenoids, carotines are there, and xanthophylls also found. Whereas in phycobilins, phycocyanin and phycoerythrin. Phycoerythrin. These are special pigments exclusively found in algae only, never found in other than the algae. Okay. Observe here, so many types of pigments are there: phycoerythrin, phycocyanin, keratin, xanthophylls, chlorophyll A, chlorophyll B, chlorophyll C. All these types of pigments are found in very primitive plant members like algae. So the right answer for this question is algae. Okay, good. What is the reserve food made in algae? Starch. Here 3 points completed. Try to remember or revise these points. One is the nature of cell wall material. Second one is the nature of reserve food material. Third one is types of photosynthetic pigments. First one, what is the cell wall materials? Cellulose, other polysaccharides. Nature of reserve food material? Starch. Types of pigments found in algae? Types of pigments found in algae? Chlorophylls, keratins, xanthophylls, and phycocyanin, phycoerythrin. Okay. Next, coming to reproduction, modes of reproduction, methods of reproduction found in algae. All types are possible: vegetative reproduction, asexual reproduction, sexual reproduction. Actually, vegetative is not a different method. Both are almost all similar: vegetative, asexual. All types of methods of reproduction possible in algae. Vegetative, it is carried out by the fragmentation. That is commonly found in filamentous algae. Fragments, long chainless structures are there. Due to some kind of mechanical forces in water, like waves and swimming of other animals, such filaments break down into small pieces or fragments. Each and every fragment is able to grow as one independent one. Each and every filament is able to grow as independent one. It is a mechanism of vegetative propagation, nothing but fragmentation in algal members. It is the Spirogyra filament. Due to some kind of mechanical forces, the filament break down into fragments. Each and every piece is able to grow as one independent organism. Next one, asexual reproduction. It is carried out by producing spores. It is carried out by producing spores. Such spores are 2 types: motile and non-motile. For example, if any kind of spore has a flagella or cilia for the movement or locomotion, such spores are called zoospores. A spore with locomotory organs are called zoospores. Or motile like animal. Zoo means animal, like motile nature is there. That's why such spores are called zoospores. Observe here clearly in the spores, flagellas are there, but number of flagellas are made different from algae to algae. These zoospores are flagellated and motile. When such are found on suitable substrate, such spore germinate to form new plantlets. It is the mechanism of asexual reproduction. Next, sexual reproduction, carried out by producing gametes. Gametes. Once again concentrate here. Fragments, spores, gametes. Gametes. Fragments are meant for vegetative propagation. Spores are meant for asexual reproduction. Gametes are meant for sexual reproduction. We can use such concepts to construct a matching type of question. Okay. Fragments for the sake of vegetative propagation. Spores are for the sake of asexual reproduction. Gametes are meant for sexual reproduction. But in algae especially, 3 types of gametic fusions are possible within the sexual reproduction. 3 types of gametic fusions. If both the gametes are similar structurally, functionally, that is the meaning for isogamy. Both the gametes are dissimilar in structurally. One gamete is the smaller, another gamete is the larger. One is the motile, another one is the not motile. That is called anisogamy. What is the full form? What is the meaning for gamy? Gamy means gametic fusion. Iso means similar. Both the gametes are participate in the fusion are similar. Aniso, unequal. Aniso, unequal. Iso, equal. If both the gametes are unequal in size and structure, that is the meaning for anisogamy or heterogamy. Ugamy is there. This story is entirely different. Here also both the gametes are dissimilar in size. One female gamete, egg is large in size, but male gamete, sperm is the small in size. Both are structurally dissimilar. But another important thing, egg is always stationary. Sperms either motile or non-motile with the presence of flagella. This kind of gametic fusion is called as the oogamy. In these two gametes, one is a motile, another one is a motile, non-motile, or egg is a stationary, but structurally both are differ. This kind of gametic fusion is called as oogamy. In algae only, in entire living world, algae only can exhibit three types of gametic fusions in the sexual reproduction. Isogamous type of sexual reproduction, anisogamous type of sexual reproduction, oogamous type of sexual reproduction found in algal members only, not in bryophyta, not in pteridophyta, gymno. What about the modes of gametic fusion in bryo, ptero, gymno, oogamy? Oogamy not only found in algae, also found in all other plant groups like bryophytes, pteridophytes, and gymnoangiosperms also. Note on this point. What is the commonest method of gametic fusion found in majority of the plant groups in the plant kingdom? Oogamy. Isogamy, anisogamy occurs in algae only, apart from oogamy. So, three types of gametic fusions are possible to present in algae. Whereas in higher plants, only oogamy is there. Whereas in higher plants, only oogamy. I will explain once again. What are the three methods of reproduction in algae? Once list out three methods of reproduction in algae: vegetative, asexual, sexual. Within the sexual reproduction, three methods of gametic fusions are there: isogamy, anisogamy, oogamy. Isogamy, anisogamy, oogamy are the three methods of sexual reproduction. So, methods of reproduction are three. One is the vegetative, second asexual, third one is the sexual. Within the sexual reproduction, three methods of gametic fusions are there. Okay, such are iso, aniso, oogamy. Near, good. Isogamy. Both the gametes are similar in size. Example for isogamy: chlamydomonas and spirogyra. Chlamydomonas, spirogyra are example for isogamous type of sexual reproduction. Anisogamy, both the gametes are dissimilar in size. Chlamydomonas. Chlamydomonas not only example for isogamy. In some of the species of the chlamydomonas, along with isogamy, anisogamy is also possible. Anisogamy. Next, oogamous type of gametic is found in volvox and one brown algae fetus. In this oogamy, female gamete is always stationary, non-motile, non-flagellated and larger. But male gamete is the smaller, maybe motile due to the presence of flagella. This kind of gametic fusion is the oogamy found in volvox and fetus. Isogamy is never possible in angiosperms. In angiosperms, only one kind of gametic fusion is there, that is the oogamy only. Not only angiosperms, gymno, ptero, bryophytes, only one kind of gametic fusion, that is the oogamy only. Isogamy, anisogamy exclusively found in algae only, never in other than the algae. Remember it. Next, another important and common feature of life cycle of the algae. Life cycle is the haplontic. In algae, life cycle is haplontic. What is the meaning for haplontic life cycle? Observe here. Life cycle in the two phases are generally found. One is the haploid gametophyte. Two generations are there in overall life cycle. Most of the plants in the plant kingdom. Second one is the diploid sporophytic generation. Two phases are there in life cycle. Gamete producing phase is the gametophyte. Spore producing phase is the sporophyte. Gamete producing gametophyte, spore producing phase is the sporophyte. Generally gametophyte in haploid condition, sporophyte in diploid condition. But significance of both the phases are variable from life cycle to life cycle. For example, I will give some colors for this two phases for easy differentiation. Pink color is given for gametophyte for easy differentiation. Blue color is given for sporophyte. I will make one more life cycle and identify the variation between these two life cycles. What about here? Gametophyte is the more dominant or more elaborative than that of sporophyte. Sporophyte is highly negligible. Such kind of life cycles are called haplontic life cycle. Haplontic life cycle. Okay. Example for this kind of life cycles, algae. Whereas in higher plants, the total story is entirely different, opposite. In algae, haploid gametophyte is highly reduced. Gametophyte highly reduced, but sporophyte is the more elaborative. Diploid sporophyte is more elaborative. This kind of life cycle is called diplontic life cycle. Diplontic life cycle. Example, both gymno and angiosperms. Both gymno and angiosperms. In primitive plants, haploid gametophyte is the more dominant over the sporophyte. Whereas in higher plants, total story is the reverse. Haploid gametophyte is highly negligible, but diploid sporophyte is highly evolved. Between them, bryo and pteridophytes, intermediate type of life cycle is there. Here also, both are significant. Gametophytic generation and sporophyte generation almost are equal or little variable. These kind of life cycles are called haplodiplontic life cycle. Haplodiplontic life cycles. Total 3 types of life cycles are found in entire plant kingdom. In algae, haplontic. Bryo and pterido, haplodiplontic. Gymno and angio, diplohaplontic, according to our NCERT syllabus. Okay, 3 types of life cycles. But the major variation between these three is the gametophyte is the completely dominant over the sporophyte. The blue color is the representative for sporo, pink is the representative for gametophyte, that is the haplontic life cycle. Whereas in bryophytes and pteridophytes, both are significant, haplodiplontic. In case of gymno and angio higher plants, haplontic phase is the gametophytic phase, the highly reduced. But sporophyte is highly dominant and elaborative. Highly dominant and elaborative. This is about the 3 types of life cycles in overall plant kingdom. So our topic is the algae. So what kind of life cycle is found in algae? Haplontic. Life cycle generally haplontic. And the zygote acts as a meiocyte. Meiocyte means the cell which is able to perform meiotic cell division, such are called meiocytes. Next point, economic importance of algae or economic advantage of the algae. Point number 1, total carbon dioxide in this universe are fixed maximum amount of carbon dioxide in total carbon dioxide fixed by algae. Around 50% of the CO2 in the atmosphere are fixed by or reduced into carbohydrate by the algae. So in this total global photosynthesis, maximum photosynthesis carried by algae. Next, being photosynthesis, they increase the level of dissolved oxygen in environment. Photosynthetic organisms not only provide food material, also that can provide oxygen. So maximum amount of oxygen we can utilize or obtained from algal members. Okay, clear? So algae is the greatest source for oxygen in aquatic environment. And these are the best producers, food suppliers for other animals are grown in aquatic habitats. Next point, These are primary producers in pond ecosystem or lake ecosystem. Number 4, many species, around 70 species of the marine algae, sea algae, saltwater algae. Example, Porphyra, Laminaria, Sargassum act as the major source for food. Porphyra, Laminaria are the types of marine algae, huge, large shaped algae. Based on shape, this kind of algae are called kelps. Kelps. Around 70 species are there in marines, which are used as a food for aquatic animals. Next, some of the brown algae, red algae produce large amount of water-liking colloids are called hydrophilic colloids. Water-holding substances. Example, algin obtained from brown algae, kerragine obtained from red algae. These are hydrophilic colloids. Hydrophilic colloids. Next, another economically important product, agar-agar. Agar-agar commonly found in or manufacturing of ice creams. Ice cream is a very soft and delicious food material. The softness of the ice cream is obtained by the agar-agar material. Agar-agar not only useful for the production of ice creams, also useful for production of some jellies. This kind of agar obtained from red algae, Gelidium and Gracilaria. Both are example for red algae. Based on type of pigments, algae classified into 3 types: green algae, brown algae, red algae. One of the economical importance of red algae is the production of agar-agar material. Example, Gelidium and Gracilaria kind of red algae are useful for production of agar-agar material. There is the Gracilaria image. There is the nutrient media prepared in laboratories. Ice creams. More than 50% of the chemical composition of ice cream is agar-agar material. In jelly, around 80% of the chemical composition is agar-agar material. Iodine is also obtained from one marine algae, Laminaria. Iodine. These are the some highly proteinaceous food supplements prepared from some green algae or blue-green algae. Such a proteinaceous food obtained from of some pills or capsules or tonics form also available. Especially chlorella species, spirulina species, these are unicellular green algae used as a protein food supplements. Within the limited space or small amount, it gives more amount of nutrition. Hence, such are used by a food supply, used by space travelers as the light-weighted food supplements. In terms of the weight, light, in terms of the size, smaller, but in terms of the protein quality or food quality is highly greater. That's why it is a more handy to carry by the space travelers. Okay, such kind of food material is also called as single cell protein. Full form of the SCP, the single cell protein. What kind of algae are useful for production of single cell protein? One is the chlorella, another one is the spirulina. Chlorella, spirulinas are served as a single cell protein producing algae. What is the important significance of SCP? Protein rich food supplements, and it is the best or handy for carrying by the space travelers. Now the classification of algae. Based on different types of pigments, algae mainly classified into 3 groups. 3 groups. One is the green algae. Second group is the brown algae. Third one is the red algae. These are common names. Botanical names or scientific names. Chlorophyceae, scientific name of green algae. Chlorophyceae, chloro green. Phyceae, suffix for algal group. Study of algae is a phycology. Study of algae is a phycology. Phyco means algae. That's why in every group one suffix word is the phyceae. Brown algae, Phaeophyceae. red algae, rhodophyceae. Three types of algae: chlorophyceae, phaeophyceae, rhodophyceae. Common name of rhodophyceae, red algae. Common name of phaeophyceae, brown algae. Chlorophyceae, green algae. It is the algal classification. Make a 3-column table and I will explain some differences between 3 types of algae. First of all, types of pigments in green algae. Chlorophyll A and chlorophyll B pigments are found in green algae. In brown algae, chlorophyll A and chlorophyll C type of pigments are present. Chlorophyll C. Whereas in red algae, chlorophyll A and chlorophyll D pigments are there. Once observe what is the major difference between types of chlorophyll pigments in 3 types of algae. Chlorophyll A is the universal pigment common in all the types of algal members. So along with the chlorophyll A, B is found in green algae, A and C are found in brown algae, A and D are found in red algae. But another accessory pigments like carotenoids are common in both. Carotenoids are common in both all the algal members. Next, especially exclusive pigments like brown coloration of the brown algae is caused by fucoxanthin. Fucoxanthin, it is exclusively found in brown algae only. It causes brown coloration of these algal members. Phycoerythrin. Erythro, red. Phyco, algae, red algae. Red coloration of the red algae is caused by the pigment phycoerythrin. Phycoerythrin exclusively found in red algae. Fucoxanthin is exclusively found in brown algae. Chlorophyll is common in all the members. What kind of chlorophylls are present in green algae only? B. In brown algae only? C. Red algae only? D. A is the common. But another accessory pigments are exclusively found in brown algae, red algae are fucoxanthin, phycoerythrin respectively. It is the comparison between different types of pigments. Likewise, habitat is also variable, structure is also variable, and form of reserve food material and form of cell wall materials are variable. I will explain remaining differences in next class. Here, in this class, various types of pigments are found in 3 different types of algae completed. Likewise, cell wall material, reserve food material, structures, examples, I will explain next class. Okay, bye now.
Hello, good morning students. So last class we might have discussed bit about coordination. As I told you, communication or coordination was supposed to happen, it's supposed to take place between cell, organ, tissue, or organ system to one more organ system, isn't it? As I told you, all these organs, organ systems, tissues, cells are actually controlled and taken care by nervous system, brain, spinal cord, isn't it? Yes, all our body systems were controlled by nervous system directly, but there are some tissues and cells and organs which may not be able to communicate with neurons directly. There are some cells and tissues which may not receive any type of wired communication to them. If you cannot depend on wired communication, then you can rely on wireless communication, isn't it? So wired communication and wireless communication. Wired communication is because of neurons, neural communication, neural coordination. But wireless communication is because of hormones. So hormone produced at one point of source will come into blood, mix in blood, reach the target and communicate with other cells and tissues. Not only wired communication, even wireless communication is equally important. So these hormones are chemicals. These might be proteins, peptides, sometimes lipid steroids also. So this chemical messenger or hormone, being a chemical, it was able to convey its message from source to target. So the communication and coordination carried by the chemical was referred as chemical coordination. So the chemical which is acting as a wireless communicator between cells, tissues, organs, organ systems. What was the name of the chemical which is helping in communication? What do you call this chemical messenger? Hormone. Isn't it? It is hormone. And which organ does produce these hormones? There are more than 40 types of hormones in our body till date, and still 200 or 300 more to be yet discovered. We did not discover every hormone in human body. There are still many hormones waiting to be discovered. We do not know exactly which hormone is responsible for increasing lifespan. We do not know exactly which hormone is responsible for behavior. We do not know exactly which hormones are very, very crucial for controlling your emotions. And we do not know exactly, does every hormone has got same function in both males and females? No. Hormones do differ among genders also. There is a study on that. So we will be discussing about fundamental aspects of hormones, and I will leave you some blanks to be filled by you. Not in class, in future. There are many unanswered questions in glands and hormones which should be discovered by you, waiting for you. Done. So hormone. The thing was, these hormones are released by special organs referred as gland. Glands makes hormones. The question was that, does every gland manufacture a hormone? No. If you have at least 30-35 glands in your body, some glands make hormones, some glands make enzymes, and there are some glands which can make both of these. And there are some glands which doesn't make any of these. See, ear glands. There are glands on your ear which neither makes hormones nor make enzymes. They make wax, ear wax. Isn't it? Sebaceous glands, they make sebum, not enzyme, not hormone. There are glands. The question was that, what was a gland? Gland was a derivative of epithelial tissue. When epithelium tissue, which was like this, when epithelium invaginates like this, the invaginated portion of epithelium now attains rapid secretion function and becomes a gland like this. But guys, observe this. When epithelium is getting invaginated, pulled into the body like this. This was epithelium, it gets invaginated like this. So when epithelium is getting invaginated, there are two possibilities. Sometimes the invaginated part will be remain as such all the lifespan. Whereas in some cases, after invagination, this physical connection between surface epithelium and gland will be lost. Like this. No more connection. The surface epithelium has lost its connection with gland. Okay. So, when this gland manufactures a chemical, the chemicals from this gland will mix into blood supply directly because they have cut their connection with surface epithelium. So, when a gland pushes their secretions into blood supply directly, such kind of glands were referred as endocrine glands. Endo, which means into, secretion, crine means secretion. What into? They were secreting into blood. So endocrine means any gland which releases its chemicals directly into the blood. Those are endocrine glands. Whereas this one, this gland, it still has a duct. This still has got connection maintained with surface. Therefore, whenever this gland manufactures any chemical, this chemical will not mix with blood. It will be sent through this duct to outside. So this secretion will not mix into blood. They will be released out of blood. Such kind of gland was referred as out secretion, exocrine gland. Exocrine gland and endocrine gland. So guys, see, exocrine gland, then endocrine gland. Isn't it? Exocrine, they do not secrete any chemical into blood supply. Endocrine gland, all their secretions will be released into the blood supply because they do not have ducts. So exocrine possess duct, we call them as ductus glands. Whereas endocrine gland, as they do not possess any kind of duct, call it as ductless glands. Okay, done. Exocrine, endocrine. Most of the secretions coming from exocrine gland usually consist of enzymes. Usually. But most of the secretions coming from endocrine glands, they possess hormones. Isn't it? Done. So enzyme secreting ductus, exocrine glands, hormone secreting endocrine ductless glands. Done. Exocrine, endocrine. So guys, there are some glands, they were mixed. I mean, some part of the gland may have duct, some part of that gland may not have duct. There is a special gland in our body which is beneath stomach. This gland is exocrine as well as endocrine also. So pancreas, 98% of pancreas possess ducts, exocrine. 2% of pancreas do not possess duct, that was endocrine. So pancreas, as it possesses both exocrine and endocrine features, pancreas was referred as heterocrine gland or mixed gland. That was one example. There are few more examples which we may consider later, but not as of now. Done? Now, I'll give a statement. Please reason this. Pancreas is considered as mixed gland. Pancreas is considered as heterocrine gland. Reason. What was the reason? Pancreas is mixed gland. Pancreas is heterocrine gland. What was the reason for telling this? What was the reason behind saying this? Guys, these kind of statements are called as assertion and reason statements. Assertion means thing you speak out very confidently without any doubt. Assertion means shouting and telling confidently. Pancreas is mixed gland. Then reason it. What was the reason behind this truth? Yes, because it's a mix of both exocrine and endocrine glands. Like that. These are referred as assertion and reason type of statements. And they may come in your objective examinations of NEET, possibly. Yes? Yes, pancreas can make both enzymes and hormones. Very good, Balu. Easy, much more easier way. Very good. Yes, because it contains both the ductus and ductless glands. Even this statement was even more good. Yes. Very good, very good. Yes. No. Okay, now, we guys know that exocrine glands include sweat glands, salivary glands, sebaceous glands, mammary glands, cereminous earwax glands, tear lacrimal glands, and largest of all, liver. All these are exocrine ductus glands. But if you ask me about endocrine part, guys, endocrine glands usually they make hormones. Therefore, hormones act as chemical messengers trying to communicate, and these endocrine glands which are manufacturing hormones are mainly responsible for chemical control and coordination. If wired communication is not possible, is not enough, is not able to reach the target location, then our body may make use of wireless communication. Which kind of wireless communication was that? Hormonal communication. Done. Like this. So, speaking about endocrine glands. Now guys, it was an exercise for you. Tell me about examples of endocrine glands which were manufacturing hormones. Give me some examples of endocrine glands. Try telling me some. Give me some examples of endocrine glands. Try them. In both males and females. In lower abdomen of females and out of body of males, there are pair of females possess pair of ovaries, males possess pair of testes. Ovaries manufacture female sex hormones, testes manufacture male sex hormones. Both these are organs as well as they can act as gland also. So testes and ovaries are combinedly we refer them as gonads. Testes in case of males, ovaries in case of females. Done? Gonads. Bit above, on top of both kidneys, we can see a cup-shaped gland like this on top of both kidneys. As these glands are found adjacent to kidney renal tissue. So this adjacent gland on kidney was adjacent to renal, adrenal gland. Even more anterior, there is a gland just beneath your stomach. It's a mixed gland. 98% was exocrine, just 2% was endocrine. What was that? pancreas. And bit above again, if you come near your chest cavity, thoracic chamber, heart, adjacent to heart there was a gland. Guys, this gland which is beneath heart, which is adjacent to heart, this gland will decide your body immune system. This gland will decide more or less how many years you live. This gland will decide your strength of your blood immune system also, your body strength too. So this, and unfortunately, this gland is temporary. It was never a permanent. So this gland dies once you reach 30-35 years of your age. After that, this gland will die away and your immune system will be definitely compromised and decreased. That's why old people were less immune than young people, because young people possess this gland, old people lose this gland. This temporary gland which is providing your immunity, what was that? Thymus. Now, I gave a fortune cookie for you. There might be a huge area of research on thymus gland. There was actually happening. Scientists were focusing on how thymus is getting died, how to delay that. If you can delay death of thymus, you can also delay death of a human. If you can delay death of thymus by just 1 year, you can delay human aging and death by at least 10 years. That was possible, and scientists were now researching on that. Thymus, very important. Memorize this. Okay. Now, just above, coming to your neck region, there were two types of glands found in neck region: ventral, dorsal. Ventral, butterfly shaped gland, that was thyroid. Dorsal, attached to thyroid, there are 4 glands. As they are again adjacent to thyroid, we refer them as parathyroid glands. Okay, these are just some examples, and more or less most of these glands were actually controlled by their master, which was found inside your brain. The master which controls most of your body glands. Who was that? Pituitary. And there was a gland which was just adjacent to pituitary, and this gland will decide when you sleep, when you wake up, when you should eat, when you should rest, time of work, time of sleep. Okay, this gland will decide your internal biological clock. This gland will decide circadian rhythm. This gland will decide biological rhythm without any dependence on this physical clock. This gland will provide you information regarding physiological functions, what you should do at which time. The gland which gives you a sense of time, gland which gives you a sense of time zone, gland which gives your body ability to rest and wake up, work and relax. This is one of the important glands which we discovered recently. We discovered gland it was very old discovery, but the main functions have been discovered very recently. This gland was sometimes referred as third eye of your body. Third eye. What was this? Pineal gland. Done. And see, even master has a master, and more or less all these glands, with very few exceptions, could be actually controlled by grandmaster, the final boss. And if this boss is actually part of your brain. What was the part of the brain which is also acting like grandmaster and is controlling every endocrine gland of your body? What was that? Hypothalamus, head. Hypothalamus was actually part of your forebrain, which is also grandmaster among endocrine glands, the main culprit behind your body behavior. That was hypothalamus. Okay, guys, these glands are inside your head. Okay, these glands are inside your throat, neck region, in throat, neck region. Done. This gland was in your thoracic chamber. Okay, this gland was in lumbar, stomach chamber, near stomach, adjacent to stomach, beneath stomach, exactly same. And this gland is in your lower abdomen, found adjacent to kidneys. Almost we can say that it was almost in your sacral region, lower dorsal abdomen. And these glands are in females in lower abdomen or pelvic region. In males, they were outside body. So I gave you locations also. 3 types of glands in head region, 2 types of glands in neck region, 1 gland in thoracic region, 1 gland in lumbar region, pair of glands in lower abdomen kidneys region. In females, ovaries in pelvic region. In males, testes out of their body. I gave you locations also. When you speak about their importance, yes. So gonads, testes or ovaries. Guys, ovaries manufacture 2 types of sex hormones in females. So ovaries manufacture 2 types of sex hormones in females. What were those? Estrogen and progesterone. Estrogen is mainly responsible for female sexual behavior, increase in size of mammary glands, high pitch of voice in females, and physiological secondary sexual changes happening in females, development of breast, increase in width of their hips, change in their voice. All these were given by estrogen. Whereas progesterone is mainly responsible for menstruation in females, and progesterone is also responsible for maintenance of pregnancy. Without these hormones, females cannot have babies. Okay, that was the importance of these hormones. Whereas in case of males, males have got a pair of testes. This pair of testes mainly manufacture the most important male sex hormone, that was testosterone. Testosterone is responsible for male secondary sexual characters. Testosterone is responsible for growth of hair on chest, body, growth of hair on face, mustache and beard. And testosterone is responsible for increase in size of your larynx. Guys, boys, testosterone will increase your sound box's volume. When your sound box, larynx increase, what happens, you know? In male voice, bass increases, treble decreases. I mean to say that male have low pitch voice. Male voices cannot be listened from more distances. Female voices have high pitch. Therefore, all these announcements in train, bus station, airplane, airports are females, not males, because male voices are low pitch. It may not reach more distance. So you can know shouting by your little brother, shout given by your little sister, which is very, very irritating. Which is very, very testing your patience, I mean to say. So male voices are low pitch. They may not affect your ears that much, physiologically speaking. But female voices have got high pitch. Listening to high pitched voices for more time may cause permanent damage to ears also, scientifically proved. Low pitch, more bass. Low pitch in boys, high pitch in girls. Okay. In alone, testosterone is also responsible for formation of sperms. Testosterone will also be useful for maintenance of male sexual behavior. Therefore, male sex hormone is mainly testosterone, female sex hormone is mainly estrogen. Like this. Okay, all of you can listen to your own voices or your friends' voices once you come here. If you type in messages, that will not be a completed communication, right? If you have to complete your communication, you have to come here and speak to each other and know each other. That's good. Guys, do not believe and trust in this online communication. There is no emotion in it, just a typed language. Okay, this typing is just a text. There is no emotion in it. Done. Like this. Okay, and bit above. And coming to kidneys. On top of each kidney, we can see a pair of a gland, that was adrenal gland. Guys, adrenal gland, if you observe adrenal gland under a microscope, the exterior peripheral part of this adrenal gland is physically distinct when compared to center of this gland. So peripheral part of adrenal gland was called as adrenal cortex, whereas the center part, middle part, was actually referred as adrenal medulla. Cortex manufacture many steroid hormones. So hormones coming from adrenal cortex are called as corticosteroids. We can also use a shortcut for this. Corticosteroids are also referred as corticoids. These corticosteroids or corticoids are responsible for maintenance of glucose balance in body, maintenance of sodium potassium balance in body, as well as corticosteroids can also manipulate your immune system. Okay, they can suppress immune systems also. And some of these corticosteroids can act as stress relieving hormones. Okay. Then medulla manufacture hormones called as catecholamines. There are two types of catecholamines which almost have same function. They differ just in their molecular formula, just slight chemical change. These two hormones are epinephrine and norepinephrine. Guys, epinephrine and norepinephrine are new names. Old names were, epinephrine was adrenaline. Norepinephrine was noradrenaline. And I should say about this now, very important. The main cause behind high blood pressure, stress, depression, all was because of this adrenaline. Epinephrine is such hormone. Both catecholamines are such hormones. These hormones will give you instant energy and help you to fight, help you to run away because you're frightened, helps you to get excited, helps you to get motivated sometimes. So flight, fright, fight hormones, and which is mainly released during stressful condition. Therefore, epinephrine or adrenaline was usually referred as flight, fright, fight hormone or simply stress hormone. This hormone is responsible for your pupillary dilation. You can see much clearly. This hormone is responsible for piloerection. Guys, body hair, pilus, it will erect, it will stand like this. What do you call this? Goosebumps. The hormone responsible for goosebumps, excitement was adrenaline. Okay, and this will increase your heartbeat, this will increase your respiration, increase your sweating, increase metabolism, and gives you instant energy to run, fight, jump, excited, do any activity. And if you have more of this hormone, exclusively in boys, too much of this hormone can also lead to sudden heart attacks. You are very familiar with the people who are died in cinema theaters while watching horror movie, right? Even when you see a ghost in a movie, you feel like thumping, shocked. This one. Sudden shocks to your heart will be given by adrenaline. That's why there is a statutory warning before a movie begins. This is not for weak-hearted people, old people, or pregnant ladies, because they have more of this hormone. Isn't it? What happened to all of you? Kept silent. Yes. Dilation of pupil. You can see much clearer pictures. Increase in heartbeat, increase in respiration, increase in BP. And if time is bad, even heart attacks may happen if it is too much produced. So, the 99% of these meditation centers or stress relief centers, their main motto is to decrease stress. Many people try to decrease stress, but most of them do not know the stress of their body was because of this hormone. It might be because of their education, job, career, or any other reason, targets. If you could manage this hormone, of course, you can live more years. But if you do not know how to manage this hormone, obviously, you may get heart diseases, you may get thyroid issues later, your blood glucose will be different, you may get diabetes mellitus slowly. I mean, I'm telling you future implications, what may happen, what may go wrong with this hormone. Okay, so controlling this hormone is most important task of your life. Blindly saying this, if we can control this exciting, shock, stress hormone, that was 90% battle won. That was the importance of adrenaline. If you go even bit top, just beneath your stomach, there is a gland attached to stomach like this. Single gland, no plural, that is pancreas. Guys, 98% of pancreas was actually exocrine in function. They secrete enzymes and enzymes for digestion. Whereas 1 to 2% of pancreas is endocrine in function, and this endocrine part of pancreas manufacture hormones. So scientists say that in a very big ocean of exocrine pancreas, endocrine part was distributed like small islands. As I told in English, if you add suffix to any term, the size of that object becomes small. Book, booklet. River, riverlet. Cigar, cigarette. Organ, organelle. Island, islet. So these were referred as islets. And as they discovered by Paul Langerhans, scientist, so named after him, islets of Langerhans. He discovered them. It doesn't mean it belongs to him. Islets of Langerhans are endocrine parts of pancreas. Islets of Langerhans secrete hormones. And hormones of pancreas mainly are responsible for maintenance of sugar level. Glucagon increase blood sugar, insulin will decrease blood sugar. Glucagon causes hyperglycemia, insulin leads to hypoglycemia. So maintenance of carbohydrates in a body was actually controlled by pancreas. If there is any damage to pancreas, it may lead to diabetes mellitus, sugar disease. Done. So we'll discuss few more points. We'll discuss more and more interesting aspects of hormones that affect on your body once you come here. Okay. We'll sign off at this point. Done. We'll meet tomorrow. Thank you.